Okay, so I know not too many people are attending at the moment live, which is fair enough because it's only really particularly valuable if you are planning on doing A-level. So I think if you're planning on doing A-level maths, you really should be tuning in, or if you're not tuning in, make sure that you watch the recording of it either on Teams or on YouTube. So I think at the moment that really is Alex, Ben and Tara, you're down as ones who are thinking about the A-level possibility. As I've said to you before, any of you who are still keeping in mind the possibility of taking the exam in September, if the grade you're allocated isn't to your liking, obviously for you guys, I think it'd be worthwhile attending too. So today's lesson is on indices. Okay, so whoops, wrong slide. Does one of you just mind confirming that you can see the slides, please? Can one of you just unmute for a second and just confirm that you can see the slide?
Yeah, we can.
Yeah, cool, thank you.
I can't see it.
You can't see it? Well, I think if one of you can.
No, I can. It just came up.
Okay, cool. So I was going to go run through the preliminary stuff about how it's all working for anybody who missed yesterday's lesson, but given it's only the two of you there, I think if anyone is watching the recording of this and wants to double check what we're up to at the moment, or if anybody wants to double check how you go about uploading all this information onto Teams, please can you watch the recording of yesterday's lesson, because I spent quite a bit of time in that lesson running through the school's thoughts on who should be doing maths at the moment and who shouldn't, and also running through how the work can be uploaded onto assignments. Okay, so anyway, so for today's work, I've sent you all through on Corbett Maths the further maths questions on indices, and I've also sent you through the answers. Okay, so I think for those of you who are really just looking to confirm your IGCSE standard of work, really you're looking at questions number 1 through to about 10 or 11 or 12. Those of you who are planning on doing A-level, feel free to look some of the harder stuff after that. I mean, you know, a lot of it is semi sort of GCSE still, and obviously you've got the answers, but don't stress too much if you can't do those. So all I wanted to do today, let me just double check I'm missing it. Yes, I'm going to turn through the pages of questions 1 to 10 just to quickly recap and just bring it all back to the front of your minds. But there was one I just wanted to run through. I just wanted to quickly remind you, because this is IGCSE standard, but it's at the higher end. So remember, if you get a question like this, where you've got the base number being different, the big number being different, you really want to make this base number here the same smaller base number. So you've got to think what number squared or cubed is going to give you either 25 or 125, and that of course is 5, because 5 cubed is 125 and 5 squared is 25. So we can replace the 125 with 5 cubed, and we can replace the 25 with 5 squared. So we've now got the same base number. So then it's our normal index rules. So where you've got a power inside the bracket and a power outside the bracket, you multiply. So obviously 3 times x is 3x. And over here we've got a claw. Okay, so 2 times x is 2x, 2 times plus 5 is plus 10. So we're saying 5 to the power of 3x equals 5 to the power of 2x plus 10. Now, by definition, both these powers must be the same number. So we can do what's called equating the powers. We can just sort of forget the 5's, if you like, and say that 3x equals 2x plus 10. And then that's obviously a very simple linear equation to solve. So we just take away 2x on both sides, and we conclude that x equals 10. So that was just one in particular I wanted to run over, because it wasn't one that was very easy. It equally wasn't one that was very hard. It's just one that's sort of at the top end of IGCSE. So the other thing I just wanted to quickly do was just turn the pages of the worksheet you've got, so just really quickly remind you of the basics. So obviously, when you've got a power inside and a power outside, you multiply. With 2a, obviously when you're multiplying, you add the powers. So 4 plus n equals 8. For part B, you're obviously, when you're dividing, you subtract the powers. So 12 take away 4. And then part C, again, you just got to do this bit by bit. So that's going to be 4n, that's going to be 18. And then because you're dividing, it's going to be 18 take away 7 equals 4n. And then you just equate the coefficients. Number 3 is pretty similar to what we've said. So here, number 4, when we're multiplying, we add the powers. So 4 add n has got to give you 1. 4b we covered. Yes, 5's a tricky one. I think with 5, that when it says work out, I think that would be a calculator question. So I'm not overly worried about that because we're subtracting here. So this isn't one where you're multiplying or dividing. So if you try question 5, just either ignore it or just get your calculator out and just use it as a calculator question. And then, yes, 6 is worth just reminding ourselves. So this power of 4 is going to attach to each of the 3 components. So it's 2 to the power of 4, x to the power of 4, and y squared to the power of 4. So 2 to the power of 4 is just 2 times 2 times 2 times 2, whatever that is. Then x to the power of 4, and then y squared to the power of 4. So that's a power inside and outside the bracket. So that would be y to the power of 8. Similarly with 6 part B. Same idea with number 7. Yeah, this is just a nice little interesting one to think about. Write the following expression orders starting with the smallest. So we're told that x is between 0 and minus 1. So think about what x would be, say, for example, at minus a half. So just go and put minus a half into each of these and then work them out and then see, and then obviously put them into order. So that was a bit different. Yes, 9 we've covered. And then, yes, 10 we're starting to get a bit trickier. But remember, if it's to the cube root, that is really just to the power of a third. So rewrite this as being w to the minus 10 multiplied by w to the minus 2, all in a bracket, to the power of a third. Then step 1 inside the bracket, when you multiply, you add the powers. So minus 12 add minus 2. And then secondly, you'll then have a power inside the bracket and outside the bracket. Just multiply those together. And then, yes, and then I think 11 and 12 is really what we've just been sort of looking at. And then, yes, and 13 is similar. So give 13 a go, because that's very similar to 12. And 14, 14 similar. You're just going to have a base number here consistently of being 2. All right, so replace the 4 with 2 squared. Replace the 16 with 2 to the power of 4. 15 will be the same idea. You want to go and get everything to the base 2 here, okay? So rewrite that 16 as 2 to the power of what? That 4 to 2 to the power of what? And that 32 has been 2 to the power of something. And again, Christian, from your point of view, this is still at the top end of the IGCSE. So if you really want to go away with the idea that you could have done everything at the IGCSE, you know, that is not beyond the level we're at. Again, nor is 16. Obviously, these are all, you can replace the 3, the 9, and the 27 all with 3s. And again here, these can be replaced with 3s. But we are getting tricky now. Anyway, I think that's enough of me waffling on. So, Christian, if you want to have a go at these, you're very welcome, and upload them, and I'll happily mark them. Alex, if you could just have a quick look at where you've uploaded it to. Yesterday's worked fine. I mean, I've gone and moved the ones that you uploaded down to below the worksheet that I'd uploaded, but that's fine. So they were there nicely. So you do know how to do it. Whatever you did yesterday worked successfully. But when I checked beforehand, unless I just missed it, I couldn't see it there. Okay, guys, that'll do. I think I'm going to go and just stop the recording. So I'm